So good morning. How are you guys doing? That's it? How are you guys doing? That's awesome. Well, I'm really excited to be here. In the next 10 minutes or so, I want to share with you a glimpse of some of the work we are doing to make it really easy for you to build cutting-edge intelligent applications wherever you need them to be. Now, this is important because we are seeing an unprecedented opportunity of using artificial intelligence to solve some of the world's greatest challenges. Whether it's using machine learning to identify patients at risk, or to help people with disabilities, or to even empower farmers to feed the world's growing population, there's a massive opportunity for developers. And what's underlying this amazing opportunity, we believe, is a foundational shift in the computing paradigm. A shift not only towards the intelligent cloud, but also towards the intelligent edge. Now, you may be wondering, what does this mean? All of us are familiar with the intelligent cloud. It's near infinite scale, it's global reach, the amazing amount of compute capacity, the massive amount of compute capacity that comes with it, etc. But what is the intelligent edge? Simply put, the intelligent edge enables you to package your models inside containers and deploy them onto the devices themselves, thus getting the intelligence very close to where the real action is happening. So how important is this intelligent edge? Today, most of the world is getting digitized. By the year 2020, we expect 20 billion active IoT devices everywhere around the planet. Now, many of these devices have very limited amount of computing power, and in many cases, at best, sporadic connectivity. But with the intelligent edge, you can enable a variety of these devices to make intelligent decisions. This isn't just theory. There are several customers that we work with that are using this capability today. Now, let's take a few examples. A great example that illustrates this point very clearly is that of the connected car. We are working with several auto manufacturers like Renault, Nissan to connect all their cars to Azure. Now, given the volume of data that gets produced every day by each car, and when you think about advanced scenarios like autonomous driving, most of these car manufacturers have realized the opportunity to actually compute and make real-time intelligent decisions within the car itself. All the cars are a part of their intelligent edge. We work very closely with Liber. They are one of the leaders in manufacturing industry. We are partnering very closely with them to build an intelligent refrigerator that uses object recognition to realize what food items are already available to create a grocery list for you in real time, even when you're not at home. All these refrigerators are a part of their intelligent edge. Rockwell is an industry leader in industrial automation. They're working on a manufacturing solution for their clients, which enables their clients to actually monitor all their machines on their factory floor in real time and make adjustments as necessary instead of waiting till the end of the day, or worse yet, when the equipment fails and they have to incur downtime. These are just a few examples of how companies are using the power of the intelligent cloud and the intelligent edge today. Now let's dig a little deeper into the next customer example that we have, eSmart Systems. eSmart Systems is basically an intelligent solutions provider for the power and the utilities industry. The key business challenge they faced was the resource-intensive way in which they were actually monitoring the electric grids. They actually had to sell field technicians into remote areas, often very dangerous and hard to reach, to monitor these electric grids. Many a time, this would happen after the equipment would fail, causing huge amounts of downtime and dissatisfaction. They built a connected drone solution to get around this problem. They leveraged the power of the intelligent cloud to train the image recognition, image classification models, given the scale that they had. Once these models are built, they basically deploy them onto the intelligent edge devices. In this case, they are the drones themselves, thus enhancing their capability to do image recognition. With this solution, now they've practically removed the need for their field technicians to go into these remote, dangerous areas. And they've also significantly improved the availability of their power grid systems. So let's take a deeper look into how all of this works. Let me work with Nishant. Hey, Nishant, how are you doing, man?
Very good, sir. Thank you.
So we know that eSmart essentially has built the solution where they're able to detect these issues in real time. But how do they get to the root cause of what happened?
That's a very good question, Rohan. As these drones collect thousands of images, all of these images are then processed through a deep learning model for object detection. Let me show you one such model over here. So here's a drone which is fitted with a lot of these sensors, collecting a lot of these images that are coming across. All of these images are sent to a storage account. We can pick up those images and leverage the open source OpenCV framework to then resize those images to fit our neural networks. And then once those neural networks are fit in over here, you can then go ahead and leverage algorithms like faster RCNN with MML Spark as well. I'm just executing one of these models over here on this particular set of images that the drone captured. Now, what faster RCNN is a state-of-the-art object detector. It can be trained to detect any kinds of objects in images. In our case, we are leveraging this to detect anomalies or damaged components within the various images that the drone captures over here. Now, once this model is processed, you can either go ahead and process it in a batch and see all of this information come across to you, or you could even go ahead and create a distributed web service. Now, this is really novel, Rohan. Now you can leverage the power of your cluster, take this deep learning model that you created, and distribute it as a REST API-based web service that can be leveraged from inside the cluster itself. And eSmart is leveraging that to their advantage over here. Let me go ahead and deploy this web service and show you what this is.
So what you've shown me so far is just sort of building and training the model in the cloud. Like, how do they get these models deployed on the drones on the edge itself?
That's a very good question. Now, the kind of things that they desire from the images is potentially accompanying all of the bounding boxes and the erroneous components. For them to have this capability on the edge, they're able to leverage Azure machine learning services. Now, because we're doing all of this in Azure Databricks, and it's so finely ingrained into the fabric of Azure, it can natively integrate with Azure machine learning services, leverage its capabilities to deploy these models by containerizing them and deploying it to the edge, in this case, the drones. Now the drones flying over these pylons are giving the information in a similar fashion that this image denotes over here.
That's awesome. All right, so I think one of the things you'd see in a moment is the amount of information that we are capturing from these drones allows us to create rich 3D models that can be used with the MR toolkits, the HoloLens that Nishant is about to wear, where you can imagine like a technician or a field engineer sitting in a remote location can actually create the entire model, virtual model right in front of them, debug it, figure out what issues are going on, what mistakes are there that caused a downtime, etc., and fix those without actually going to the actual location. So let's see that in action.
Certainly. Here I'm wearing one such HoloLens, which gives me a very good view of the entire landscape of information that people can access. I can see the case information, I can see real-time information from analytics that I have performed. I can even see some of the issues that have been highlighted over here. And I have a 3D layout of the map as well that I can play around with. Now let me just dive into one of these issues over here. I'm diving into one of these issues over here as it comes across, and I can see all the images that have been captured from the drone. But what's even more interesting is that since these have LiDAR and IR scanners, I can recreate the issue in a hologram right in front of me and even tap into some of these components over here. I'm going to tap into this erroneous insulator because it highlighted that in red, and I can dig into it over here as well. Now, since these are 3D models, I can start interacting with them to see what has gone wrong. I can clearly see that there is a chip in this particular insulator model over here. But what's even more interesting from the perspective of the HoloLens is that I can see that there is weather-related wear and tear on this side of the insulator as well. Now I wonder if I should change the component and actually go ahead and try out a different material for this. Well, why not? Here, I've just changed the component over here, and I'm running a simulation, again, using machine learning models residing inside of Azure Databricks to see real-time feedback loops on how this new material is going to behave if I replace it over there. I love this component. I think I'm going to replace the changed one over here. Let me go back and create a ticket. But before that, look at this. I selected a different component. So now it's showing me all the machine learning output and material over here that is useful for me to absorb the information before I make the decision and create a ticket. I like it. I'm going to go ahead and create this over here. Now I'm going to replace the existing one and go ahead and create a ticket. Now that is the true power when you mix reality and when you bring it all together with the intelligent cloud and the intelligent edge. We invite you all to come experience this at the booth as well. Over to Rohan.
Thank you, Nishant. So this, by the way, is not science fiction. This is exactly how eSmart Systems is using the power of the intelligent cloud and the intelligent edge and the MR toolkits to solve problems. You know, the ticket you saw created creates a workflow for the technician to go fix it only when they need it. Now, let's look at some of the results that eSmart, once they deployed the solutions, what did they get? 70% fewer work-related injuries, right? Because the technicians were not going to these remote, hard-to-reach, dangerous locations when they didn't need to. 40% reduction in carbon emissions, and 35% reduction in unexpected and unplanned downtime for their customers. That's huge. What we've seen today in brief 10, 12 minutes over here is how companies and organizations are transforming with artificial intelligence. While that's great, we believe AI is much more than that. It's really about empowering people as well. We believe all of us have a fantastic opportunity to make a positive difference in the world, and we want to be a part of doing that with you. Here's the last video that captures our sentiment around this. Thank you.